Hello and welcome to another video. Today we'll be going through how to create auto-scaling groups within AWS using Terraform. As we can see in the architectural diagram, within AWS we'll be creating a VPC, and within this VPC will be 3 public subnets that then contain 3 EC2 AMIs. 2 of these are going to be lightly fainted out because they are managed by the auto-scaling and load balancer rules. Maximum of 3 with a minimum of 1 as shown here. You can also see the load balancer configuration is pointing down to show that we'll be configuring the file to scale down if demand is lower. That's the Terraform file. And here the CloudWatch metric alarm pointing to the EC2 image will monitor CPU utilization. This will notify us if the threshold is ever met. So I haven't included application load balancer and target groups into the diagram, but to explain how they would work, application load balancer would point to the target groups with a quotation saying listens on port 80 HTTP, and the target groups would point to the EC2 image or images and also have a caption on port 80. Alright, so let's move on to the Amazon console real quick. We can see at the moment that nothing is running, only the security group and a key pair, which was for a different EC2 image, the default security group and key pair for a different project. So we're going to create everything from scratch within Terraform. First we need to create the versions Terraform file. Yeah, just wanted to make sure it's in the right directory. So yeah, first versions.terraform. In this the minimum version for the HashiCorp source or AWS HashiCorp source is 3.3. The required version is anything above 0.15 for Terraform in general. And we can actually check this with Terraform. Yeah, so we can see the versions here above the minimums. Nice. Yeah, so let's create the outputs Terraform file. Within outputs, I'm going to be creating the load balancer endpoint, the application endpoint, and the ASG name, which is the auto scaling group as valued here. Next, let's go on to the main Terraform file. For simplicity, I've kept the bulk of the information within this main Terraform file, but as some of you well know, we could create the provider Terraform file for this. The provider is going to be AWS as previously stated, and the region will be US East 2. Default tag is HashiCorp learn and AWS / or -ASG. You can configure this how you please, it's just a tag. Next, we want to start with the availability state. Now the availability zone state is available, which is optional, but the choices range from information, impaired, available, which is what we've picked for this instance. The module for VPC is next. Yeah, so let's get started on the module for VPC. And then the source is Terraform AWS modules /VPC /AWS. And then we need to specify the version as well. That shouldn't be there. So source is Terraform modules page, and version far from the latest, which is 2.2. I think the recent or the most latest version is around 5 point something. The name will be main VPC for now, and with the standard CIDR block, we'll name it main VPC for now. CIDR block, we'll do the standard 10.0.0/16 to start. And we need to also mention the AZs or availability zone from the previous data we provided above here. We can also specify Yep, so we need to also specify the ASIO availability zone above, like we've done. We need to reference it here, and then we need to do the subnets for this. So the public subnet, more clear, public subnet. So this one's gonna follow, it's actually gonna follow the same ones we noted in the diagram here. So yeah, the subnets are standard subnets described in the architecture, and I'll be also enabling DNS host names and DNS support. This is not something I would recommend if you're building it for a production database. Okay, so next is the AWS AMI. My one's going to be Amazon Linux, and the most recent is what I want. True. So yeah, as of December 2023, Amazon actually discontinued the standard Linux AMIs. So data.aws, just to show you what that would look like, data.aws, and then owners equal Amazon. This would not actually return any results. Instead, you have to use Linux 2, which is the most updated pattern of AMIs, and that would look like this. Dot name. So yeah, this might not be necessary. And then with this, this for the specific Amazon Linux 2 pattern, and then those are done. So with resource AWS launch configuration, it did not work for me initially, even though I referenced the image ID. Also noticed you need to reference the instance type. So what I've sort of changed here, I'll show you the resource AutoScaling group. Need to give it a name, which is going to be Terra tutorial. I've just taken the quotes from that quote. Yeah, so with resource, need to give it a name. To I think minimum size, wrong, minimum size, desired capacity, and the launch configuration. Oh, it just gets more difficult. And I'd say maybe VPC zone identifier. Yeah. Alright, so to explain these, the name that we're going to give the AutoScaling group is going to be consistent with Terra tutorial. The minimum size is going to be 1, because we want it to run, and it's actually an integer. Maximum size, we'll say about 3, as described in the architecture diagram. So yeah, you only need 3. Potentially I can change this to 6 if needs be, because there's the 2 availability zones. Desired capacity is 1, so this allows it to, so it can be scaled down if needs to. So we've kept the desired capacity to 1, and the launch configuration is going to be AWS launch configuration, with the Terra tutorial name and name, and the VPC identifier is going to be the same VPC name that we've given it. So module.vpc.public subnets. Okay, so those are done. Desired capacity, did I spell that wrong? Capacity, there we go. Desired capacity, and then we need to also add health check grace period. No, we'll just do the type for now, which is going to be ELB for elastic load balancer. Then we also need to specify the tag. The health check type, it's optional. It ranges between ELB and EC2, but we only need ELB for this instance. And in addition to the tag, we need to also specify that we want it to propagate at launch, which is actually a required command, so we'll specify that as well. So first key equals name, and then we'll add the value. The value will be learn ASG Terra tutorial. We actually need one more space, and this is to propagate at launch. Yep, there we go. Now the errors have gone away, and it only needs to be true. Also, for the AutoScaling group, we need to add the AutoScaling policy. This AutoScaling policy allows us to do scaling adjustments. So when we say -1 from wherever it currently is, to scale down when it's at max size 3 or maybe even 2. We also need to specify things like the adjustment type as well as the cooldown period. So let's get started with that, which is resource. Alright, it's already given me one. AWS AutoScaling, and then policy. And then from the policy, I can specify the type of policy, which is going to be scaled down. We also need to scale an adjustment, and that will be -1. Adjustment type, which will be the change in capacity, and the cooldown in AutoScaling group name, around 120 seconds, and AutoScaling is going to be AutoScaling group name, and then we'll reference the AWS AutoScaling group and then Terra tutorial. Perfect. Okay, now the CloudWatch metric alarm is gonna need, so let's go through them while I create them. This will also be scaled down because that's what we want to use it for whenever we want things to scale down. So the alarm name is first. We'll keep it here. So that's going to be Terra tutorial once again. Terra tutorial scale down, just like with the scaling policy. The comparison operator, that's going to be less than or equal to threshold. So the comparison operator is an arithmetic operation that can also be used as a trigger to scale instances down. The evaluation period, yeah, so as you can see, when the error is gone, these are the required ones. This is going to be, we'll make it 2 minutes, specify that 2 minutes. And then the metric name, we'll name this CPU utilization, as that's what we want it for. And then namespace is going to be what we're using, which is the AWS EC2 EMIs. We don't need to specify the AMI parts, we could just say AWS EC2. The period is 120. Yep, so the evaluation period is the time the period which the data is compared to a specific threshold, which is going to be this, and I've stated for it to be 2 minutes. The metric name is the CPU utilization, as it's what we're going to be keeping an eye on. The namespace, period, statistic, and threshold are all optional, but they've been set for clarity. And lastly, for this, I think we need the dimensions. AutoScaling group name. I want to name this a bit differently to the previous ones I've got. Then we can close that off and delete that. Great. We need to also add an alarm description, and we also need to add the alarm actions. So just to simply state, this metric monitors EC2 CPU utilization, and this one is going to be linked to the AWS AutoScaling policy, and then we're going to add the scale down.arn, and something's not right. That's okay. I've missed a bracket somewhere. Alright, cool. So that's done. So to explain the dimensions are the alarms associated with the metric. They can be set for a few AWS services, but for now we only need them for the auto scaling. And the alarm descriptions are just to add information for if or when the alarms go off. And now we need to do the application load balancer. And then that there. Name is going to be learn AutoScaling Terra tutorial load balancer. LB for short should be okay. I think might want to make this a bit further out. And then internal equal false. So internal configuration is optional, and it will default to false anyway, which is what we are currently using it for. The load balancer type we need to specify is going to be application. And we also need to specify the security group and subnet for it. Just to explain the type. The type is application in our case, but it can be used for other things such as gateway or network. And we also need to specify the security group and subnet. The security group is going to be the security group territorial load balancer, so pretty much with the same name. And then we need to add LB ID, and then subnet is part of the VPC that we've already created. Module.vpc.id. It's actually more than one subnet that we've created. Next, we need to do the load balancer listener. It's a process that checks for connection requests. We need to create at least one listener for the load balancer to work, and it's going to be using the protocol and port we configured, which is AT-HTTP. So resource load balancer again, but this time add in listener, and we will name it Terra tutorial. So for this we need to specify the load balancer ARN, and this one's going to be AWS LB. The port, as earlier stated, is going to be AT, and the protocol is HTTP. Let's see if it will change after I add the default action and maybe in the targeting group. So for the routing action, first default action, oh yeah, perfect. Type is going to be forward, and the target group ARN. Target group ARN. AWS load balancer target group dot Terra tutorial.arn. Target, that's why. Yep, so target group ARN. And now we need to create the auto scaling attachment in addition to the load balancer and load balancer listener. So the auto scaling attachment will include the scaling group name and the target ARN as well. The auto scaling attachment is resources used to associate the auto scaling group with the target group. This is usually essential for load balancing across instances launched by an auto scaling group. So a resource as I said, the auto scaling group name and AutoScaling, and also the application load balancer target group ARN. So yeah, where the application load balancer will be targeting, and that first the group's going to be AWS AutoScaling group.id, which we've already specified, and this one's going to be AS target group.terra.tutorial.id. Okay, now we also need to create the AutoScaling attachment, which is a resource that's used to associate AutoScaling group with a target group. This is essential for load balancing across instances by AutoScaling group. So first let's specify it. Resource, definitely not that. Is AWS AutoScaling attachment, and then we'll name this Terra tutorial as always. And now next we need to do the AutoScaling group name. We also need to do the load balancer target group ARN. Great. So the load balancer will be tutorial.id, and then the group name, AutoScaling group name, would be sort of the same with AutoScaling group tutorial.id, just to make sure it can reference from them. Finally, we need to do the two security groups. One is going to be for the instance and the other one's going to be for the load balancer. So let's start with the instance, and then the name will be Terra tutorial underscore instance onto the name, and that's going to be learn AutoScaling groups Terra tutorial instance, and we need to specify the ingress for the group as well as the egress. So this will be the inbound ports, outbound ports. So from port 80, which is the HTTP one, and to port 80, and then the protocol security group, it's going to be associated with a security group Terra tutorial load balancer ID. It's going to be the one for the load balancer, so I'll add lb.id to it. And then we need to create egress rules. Egress, why is it equals? This will be allowing it to go outbound anywhere. And then the protocol will be -1 for any, and what I need here is the cider block, and then specify this as that looks okay. And then I could specify the VPC ID as module, well, nope, module.vpc.vpc underscore ID. And now we need to do the second security group, and this one is going to be for the Terra tutorial load balancer. Let's copy these and make adjustments. So ingress from port will be 80 TCP, and here we can actually switch out the cider block. You can type it and then get rid of that. And then we need to do the egress rule, and then from port is going to be 0 to port equals 0. Protocol will be allow any, which is -1, and cider block says doesn't need to be IPv6. And once that's done there, I can do the VPC again, and this one's going to be the same VPC. It's VPC underscore ID, and then yep, that one's done. So these two have the same settings around the ingress and egress rules. The port is 80, and egress rules allow any, so it allows it to go anywhere outbound. Now that these have been created, so yeah, let's save these first, and then we'll Terraform initialize. Great, that's done. So Terraform plan, it should add around 20 resources. Yeah, so the plan was to add 20 resources, so you know everything's set and ready. So let's apply this and then have a look in the AWS console. Okay, so all of these have now been created, all these resources. So let's have a look in the console. Refresh this. Okay, great. So we can see the two security groups are created. One instance is running, auto scaling group, volumes, and load balancer. Let's have a look at these one by one. The security groups as specified running. So the instance is running T2 micro within the assigned zone, and we can see the tags are applied, which is great. Alright, let's have a look at the auto scaling group. Yep, so minimum 1, maximum 3, desired capacity stated. Yeah, the availability zones within US2, and volumes here 8 gig, nice, and load balancer here created within 3 availability zones. Alright, that's great. So ways could possibly improve this project is by improving the security group rules, but to also include maybe SSH rules for test if I wanted to launch a web page on top of that. Let me know if that's something you'd be interested in. Thanks again for watching, and please don't forget to Terraform destroy.